So students, today we are going to continue with the properties of definite integral. In last lecture, I had proved two properties of definite integral for you. Today we are going to prove two more properties of definite integral. So this is property number 6 in the list of 7 properties which I had written for you in last lecture. So to prove that, to prove that 0 to 2a 0 to 2a f of x dx is equal to 0 to a f of x plus f of 2a minus x dx. We have to prove this. What I understand here is to prove this, see, I need to prove that 0 to 2a f of x dx is equal to 0 to a f of x plus f of 2a minus x dx. So I understand that in order to prove this, I will have to prove 0 to a f of x dx plus 0 to a f of 2a minus x dx. So in order to prove 0 to 2a f of x dx is this, I will have to prove this. They are one and the same thing. Okay, they are one and the same thing. To prove this is same as prove this. They are one and the same thing. Here I have got common integral and here I separated the integrals. So I will begin with my left hand side. The left hand side here is, see, the proof will start as follows. I write proof and I will begin with LHS. I will write let I equals to 0 to 2a f of x dx. And the next step, what I write is, I use the property. Which property? If you remember, we have a property where I have a to b f of x dx, which can be written as a to c f of x dx plus c to b f of x dx. A to b can be written as a to b can be written as a to c f of x dx plus c to b f of x dx, provided this number c, which is the intermediate number c lies in between a and b. That is, number c is greater than a but lesser than b. Okay, so you had a to b, you wrote a to b as a to c plus c to b. Now this property I'm going to use on my LHS, left hand side. Okay, left hand side of the theory which I am proving. So here 0 to 2a. See, what will I write? I will write 0 to 2a as so when I do this, I get I equals to, see, I'm using this property here. I'm using this property here. So I get 0 to a 0 to a f of x dx plus a to 2a f of x dx. What I did, I had to integrate from 0 to 2a. I had to integrate from 0 to 2a. So I split this. I split. How did I split? I split from 0 to a and then from A to 2A. This A lies in between 0 and 2A. A is greater than 0, but it is lesser than 2A. It is lesser than 2A. Okay. So next we get, therefore I equals to, the next I write, therefore I equals to 0 to A f of x dx plus, this one is I dash. For this, I write I dash. Okay. And this is my equation 1. Now, what I want to tell you here is, I want you all to check what you had to prove. See, students, this was our aim. My aim was to prove that 0 to 2a is 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now, in this, I have already achieved I have already achieved the I have already achieved the first integral. See, this integral we have already obtained. You see this? This integral has already been obtained. So the only aim that now I have is that somehow I prove that this I dash is equal to this. Okay. So what I'll be doing, as I know that I have written I dash for this integral, now my aim is to prove that this integral a to 2a f of x dx is same as 0 to a 0 to a f of 2a minus x dx. Okay. I repeat once again everything. See here. Let us have a quick revision of what we did till now. So this was the property that we had to prove. This is property number 6. Now here I noticed that on the right hand side, we have got sum of two functions. So in order to prove this, it is same as proving I split the integral, like I wrote two integrals here. And then I started with LHS, which is 0 to 2a. I use the property 0 to 2a f of x dx. I use the property here, and the property is 0 to a plus a to 2a. Okay, we can split this interval into two intervals. 0 to 2a, I split in 0 to a and a to 2a. Now, having done this, I observed that what I needed to prove, what was my aim, in that I have achieved 50%. Okay, this 50% has been achieved. So the only aim now I have, that somehow I get this here, somehow I get this in place of I dash, which is this. Okay, so I will now start working on I dash. I will start working on I dash. So here I write consider I dash. I dash is a to 2a to 2a f of x dx. So what do I want in place of a to 2a f of x dx? We all know in place of a to 2a f of x dx, what I want is 0 to a f of 2a minus x. Okay. In place of that, I want this. So here I will start with my, if you remember, even in last lecture, I had given you some trick. Okay. So what I would say, I would say that here I have x, here I have x, and what I want is 2a minus x. I have x here, and what I need is 2a minus x, right? So I would say that, so here I write, this is my task. What is the task here? The, the task is, x should get transformed into 2a minus x, right? X should get transformed into 2a minus x. This is my task. Here it is x and I want 2a minus x. Now what I do is, this is my goal side. 2a minus x is my goal, my objective, my aim. Now this side where I have variable x, this I will write as t, and that will become my substitution. This will become my substitution. So remember students, this is trick. This is the key. This is the key of the proof. Okay. So I write here. So see here what I write. I write put x equals to 2a minus t. Now I write differentiating with respect to t. So I get here dy dx of x is 1. Sorry, we are differentiating with respect to t. So I write here. You could have differentiated even with respect to x. That doesn't matter. So d by dt of x equals to d by dt of 2a minus t. So you get dx by dt, you get dx by dt equals to 0 minus 1. Derivative of 2a is 0 and derivative of t with respect to t is 1. So you get dx equals to minus dt. What do you get? You get dx equals to minus dt. And then what you do is you will now change the limit. You change the limit so that you can write the new integral. See, this limit a to 2a is for x. Limit a to 2a is for x. This is 2a minus x. So here I write when x is a, and here I have when x is 2a. When x equals to 2a. What was the substitution that we used? We put x as 2a minus t. So here I will write a. This is the substitution. Okay. So in order to get the limits for this limit, a to 2a is for x, and you want to get the new limits for that, you will have to use this substitution. So a to 2a, when x is a, so here you will write a equals to 2a minus t, a equals to 2a minus t. So you can shift that t there and a here. So t equals to 2a minus a. So t equals to a. So when x is a, t is a. Okay. When x is 2a, so you have 2a equals to 2a minus t. So 2a cancels, you get 0 equals to negative t. So t equals to 0. So what I get here is, I understand that it is the new limits are a to 0. So I will write therefore I dash which was a to 2a, it is now a to 0, and f of t, because you have written, sorry, x is 2a minus t. I'm sorry. So this is f of 2a minus t. You are writing x as 2a minus t. And what is dx? Dx you will be writing dx is minus dt, minus dt. I take this minus out, so I get therefore I dash equals to negative a to 0 f of 2a minus t dt. And here what I do, I use the property. You remember which property I'm talking about? Yes, correct. We will invert the interval. So here I write using a to b f of x dx as negative of b to a f of x dx. We get what we get. This I dash will become, see, I dash is negative a to 0. So when I write 0 to a, I will put one more negative sign, it will become positive. 0 to a f of 2a minus t dt. 0 to a f of 2a minus t dt, right? So here I get, now after this one more property we will use, which is I write using a to b f of x dx is same as a to b f of t dt. This property helps me change the variable if the interval and the functions are retained. If you keep the same interval and same function, you can always change the variable. So I write a to b f of x dx is a to b f of t dt. Therefore, I dash is equal to, this is 0 to a. So this is 0 to a, f of 2a minus t dt is f of 2a minus x dx. See, I achieved my goal. So here I will write using I dash in 1. I write here using I dash in 1. I dash in 1, we get what I get. I get I equals to 0 to a f of x dx. I equals to 0 to a f of x dx plus 0 to a f of 2a minus x dx. Okay, and what was I you already know. I was this is something that you took it as I, right? So I will write here, I'll write here therefore 0 to 2a, therefore 0 to 2a f of x dx is equal to, I take common, I write common interval, so 0 to a f of x plus f of 2a minus x dx, hence proved, hence proved. So I suggest you all to write this in your notebook. This is an important theory asked in board exams for proving whether it is state board or respective board, whatever it is, state board, CBSE board, ISC board. In all these boards, these proofs have been asked several times. You can take a note of this. So the next one is seventh property in the list which I had given you, and that is property of even and odd function. So there, what was the property? To prove that negative a to a f of x dx is equal to 0. It is equal to 0 if this f, the function, if f is an odd function, if f is an odd function, and this equals to 2 times 0 to a f of x dx if f is an even function, if f is an even function. So there are two cases here. Once f is even function and the next is f is odd function. Now here what I will do is I will teach you this with the help of a flow chart. So what I do for you is so here I make this theory look more simpler with the help of this flow chart. And what is it? You will know in a short while. So, my dear students, what I do is I write here minus a to a f of x dx at the top. So in this box, I have minus a to a f of x dx. Now this minus a to a f of x dx becomes 0. What does this become? This becomes 0. See, this is 0. You can see this branch. So this is equal to 0. You can check this out. Minus a to a f of x dx is 0. When does it become 0? When f is an odd function. So here I write f is an odd function. Okay, this side. And this minus a to a f of x dx becomes 2 times, it becomes 2 times 0 to a f of x dx when f is an even function. F is an even function. Okay. Now remember one thing. There are two cases here in this theory. Now whether you want to prove for odd function or you want to prove for even function, mind one very important thing, that you will have to first prove something different. Okay. This is intermediate block, which deliberately I had not put. Now I put it here. See, whether you want to go for odd or you want to go for even function, you will have to first arrive at this intermediate block. That is, you will have to prove this one first. Okay, so whether you want minus a to a f of x dx to be 0 when it is odd, or you want minus a to a f of x dx to be 2 times 0 to f of x dx when f is even. Okay, either of these two you'll be able to prove only when you will have proved this intermediate step. And what is that intermediate step? It is minus a to a f of x dx is 0 to a, it is 0 to a f of minus x plus f of x dx. Now, unfortunately, what happens is that when you get this theory to be proved in exam, as you saw here, in exam, the question paper will have such a theory to be proved. In question paper, you will see this. In question paper, you will see this thing. Now, it is unfortunate that in the question paper, you do not see the actual expression that you need to prove. And what is that actual expression that you need to prove? It is this. And in exam, you don't see this. Now, since you do not see it, most of the students find this property to be proved difficult. It is something which you will have to remember. You need to remember this. When you remember it, then only you can prove it, and hence you can go ahead. So in exam, you get this theory to be proved, but you should remember that you can prove this one only when you prove minus a to a f of x dx is equal to 0 to a f of minus x plus f of x dx. So this is something that you have to prove. Now, once I get this, after that, I will apply two cases. That is, I will apply for odd function and even function, and respectively, I will get my proof done. Okay, so now I have explained this in detail. What is the goal? The goal we have is we will begin with this and we will first prove that this is equal to this. Once I achieve this relation, after that, whatever relation I want, I'll be able to prove. So the theory, the proof now starts. I write here proof, I write proof, and I write, okay, so what I have to prove, just wait, let me write that once again. So here I have now to prove that minus a to a f of x dx equals to 0 to a f of minus x plus f of x dx. Forget about that even function and odd function right now. This is your main, whichever they ask you, whether they ask you for for or if they ask you this in exam, you still have to prove this. You have to first prove this, then only you can get that. If they ask you prove this equals to this, you still have to prove this. Once you prove this, then only you'll be able to get for even function. Okay. Once you achieve this goal, the rest is assured. So here I go ahead. So this is something my aim is. So I write that is minus a to a f of x dx is equal to, let me split this. So 0 to a f of minus x dx plus 0 to a f of x dx. So this is my actual goal. Now here I will begin with the proof. So my dear students, till now it was only the understanding part of what the theory actually is. So here I will begin with my proof. This is my I. I write here, let I equals to minus a to a f of x dx. Let I equals to minus a to a f of x dx. Now here what I write, I use the property. Which property? Which property do I use? I use the property where I will break the interval into two intervals. So I write here, I write here using a to b, f of x dx equals to a to c f of x dx plus a to c f of x dx plus c to b f of x dx. Okay, I use this and see what do we get. We will get I get here I equals to, see, this is minus a to a. I will break minus a to a as minus a to 0 f of x dx plus 0 to a f of x dx. And why do I do that? Because 0 lies in between negative a and positive a. Okay, here also in the theory, I write c is greater than a, lesser than b. Okay, this intermediate number has to be greater than the lower limit and lesser than the upper limit. Okay, so minus a to a. If you see the interval minus a to a, if this is negative a and this is positive a, definitely 0 will lie in between. So what I'm doing, instead of taking one interval, complete one interval, I break this into two interval. I take this interval and then this interval and I add them. Okay, so this is one property which we have used. The next we now do here is, see, now having proved this much, what I notice? I notice that the right hand side of my theory, which I needed to prove, this is something I wanted to prove. So the right hand side of my theory and the right hand side of what I have achieved so far, I notice that 50% is already achieved. See, this one which I wanted to have on the right, I have already achieved. 0 to a f of x dx has already been achieved. So the only goal now I have is, in order to complete the whole proof, that I'll have to prove that this integral here, which I have, is same as this integral. Okay. So if I prove this integral is same as this integral, what I'll be doing? I'll be completing my proof. In place of this, in place of minus a to a f of x dx, okay, I will prove that this integral is same as this integral. So it will be replaced. And once I get this one here, if I get 0 to a f of minus x dx here, you can just see that we will have proved, we will have completed the proof. Okay, so here we begin. So my aim is I want to get this equal to this. So here I start. I will write now. I will write here I equals to, this is I dash, write it as I dash plus 0 to a f of x dx. This is 1. I write consider I dash. I take this I dash out, so consider I dash. What is I dash? I dash is I dash is minus a to 0 f of x dx. Okay, now what I notice, so here I start with the trick which I always tell you. So my task here is, what is my task? My task is, you can check, see here you got x and you want it to be f of minus x, that is you want it to be minus x. So you will want, in place of x you will want minus x. Now so this is my goal side. Now, as I always say, on the goal side, that is your aim. So this is your aim. You, in place of x, you want minus x. You replace that variable by t, and this becomes your substitution. This becomes your substitution. Okay. So this is very important part which you'll all have to always take care of. So here I write put x equals to, I write here put x equals to negative t, put x equals to negative t. Okay. On the goal side, on the aim side, it is only that variable which you replace by t. Rest everything you write as it is. So here put x equals to negative t, I write differentiating with respect to t. So I get d by dt of x, and here I get d by dt of minus t, which is minus 1. So I get dx equals to minus dt. The next step is I will now change the interval, change the limit. Why? Because the given limit is for x and we are writing it for t. Okay. So here I write here when x is, I write here when x is, see it is negative a to 0, which is for x. I write here when x is minus a and when x is 0. So when x is minus a, I write it here. So see, what do I get? I get minus a equals to minus t. So t equals to a I get. And when x is 0, negative a to 0 it was. So I first went for negative a, now I go for 0. So when x is 0, I get 0 equals to minus t, so t is 0. So the limits for t will be a to 0 instead of minus a to 0. So I have therefore I dash equals to a to 0 f of minus t, x is minus t, so f of negative t, negative dt. So what you get? You get here minus outside, so minus out a to 0 f of negative t, f of negative t dt. So this negative sign will come out. I get negative dt. This is my I dash. And at this step, we will use the property. Which property? The property where we will invert the interval. It is a to 0. We will make it 0 to a. And when I'll make it 0 to a, I will put one more negative sign. I will put one more negative sign, because of which this will become positive. Okay. So I write here using a to b f of x dx is equal to negative b to a f of x dx. We get what we get here I dash equals to I dash equals to 0 to a. Remember, it was a to 0 and outside you had a negative sign. But now that negative will not come. So 0 to a and you have f of minus t dt. So now we will use another property here in which we will change the variable. So I write here using a to b f of x dx equals to a to b f of t dt, and this will become therefore. We get here I dash equals to, it is 0 to a minus t dt, it will become 0 to a f of minus x dx. Okay, and this I use in 1. Okay, here I use in place of I dash, I will write what I got. And remember, students, this is something that we were longing for, we were waiting for, so that we needed and we have achieved it. So I write using I dash, I write here using I dash in 1. Using I dash in 1, we get. So what we get? We get I dash, sorry, I equals to, see, it was I equals to I dash. I equals to 0 to a f of minus x, 0 to a f of minus x dx plus 0 to a f of x dx plus 0 to a f of x dx. I will write common integral. So I equals to 0 to a, and here I have f of minus x plus f of x dx. F of minus x plus f of x dx. Okay. And students, what was I? Do you remember what I was? I was this minus a to f of x dx. So remember that first part you have proved. The main required thing in the theory you have already proved. So see, if I replace I by minus a to a f of x dx, so you have proved the first main required part. This is the first main required part. I have proved that this is equal to this. Once it is done, once you have achieved this, the rest becomes very simple. How? See, I'll tell you that. I write this as 2. I write case, now I take different cases. I write case 1, and here I write when f is an odd function, when f is an odd function. Now you all know what happens. See, when f is an odd function, f of minus x is, f of negative x is negative of f of x. You understand? I write, therefore, 2 becomes, what will 2 become? 2 becomes, see students, f of minus x is minus f of x. So here you will write minus f of x. You will write here minus f of x. So what it will become? 2 will become, see, you will get here minus a to a f of x dx equals to 0 to a. What is f of minus x? Minus f of x. 0 to a minus f of x plus f of x dx. Minus f of x plus f of x dx. Minus f of x plus f of x dx. So you will get therefore minus a to a f of x dx equals to, check, what is minus f of x plus f of x? This is 0. You got 0, 0 to a 0 dx, which is equal to 0. See, you just put f of minus x as minus f of x, and what happened? These two got cancelled. See, they got cancelled. You got 0, and it is done. So you understand that whether it is even function or odd function, the most important part in this theory is establishing this relation, that is intermediate relation. Okay, so here we got, so therefore minus a to a f of x dx is equal to 0. Minus a to f of x dx is 0. The first part is done. Now I have case 2. Okay, case 2. See here, I write case 2. What is case 2? In case 2 we have, case 2 is when f is an even function, when f is an even function. So now you know, if f is an even function, what will happen? So when f is an even function, f of minus x is equal to f of x. Therefore 2 becomes, what does it become, students? You will have here minus a to a f of x dx. You will have here minus a to a f of x dx is equal to 0 to a 0 to a f of minus x. What you will write? You will write f of x plus f of x dx. Okay, so what will it become? It will become, therefore minus a to a f of x dx equals to 0 to a, this is 2f of x, 2f of x, and that 2 will go out. 0 to a f, and that 2f of x, I write 2 out. So 2 times 0 to a f of x dx. And see, I have proved even for even function. So I hope you all must have understood. This is the end of proof of property number 7. Okay, you should all write this completely again and again and do the better practice for this. Thank you.